Imagine a world without plastic waste, without microplastics in our drinking water, without microplastics in our bodies. Imagine a world where the air you breathe isn't toxic and polluted, but of the quality you deserve. Imagine a world where you get your favorite phone in mushroom packaging. That world is possible now, because we are making the mushrooms that will help the world. The idea to create Biosporin came from a variety of sources. So our company has been very diverse from the start, and part of the company worked on designing partially sustainable or green material, promotional materials for promotions on airports or similar things. And while during that we noticed that there are not many suitable material substitutes for plastic materials around. Simply, if you want to go green with promotional material, you have very little choice, and some big installations that are made for airports and similar stuff require a lot of styrofoam, and they're used only for one season, they're used only for holidays or something like that, and then they're thrown away. Another source came about at the same time that we were producing pharmaceutical mushroom, which is used to produce supplements and pharmaceuticals. And while growing it, we noticed that the mushroom material has a lot of special qualities, and one of them is that it can, in certain conditions, be used as a material that has almost the same characteristics as styrofoam. So we noticed that, but it didn't really click until we were also aware of the other issue. And then the idea came about to use the mushroom material and create a sustainable and biodegradable substitute for styrofoam. That was a little over 3 years ago. So development has been for about 3 years. It took us about 1.5 years to create the first prototype of the material, which has all the technical characteristics of styrofoam or of expanded polystyrene, and then another 1.5 years to make it into a suitable, commercially viable product. So the big 3 problems, let's say, that we are solving with our material is, number 1 is plastic pollution. So microplastics and generally removal of plastics, environmental issues, let's say it that way. The business perspective, from which we know that legal action has been taken to reduce single-use plastics. And a lot of countries are banning the use of single-use plastics now, which will create opportunity for business and opening on the market, where businesses will have to transition into a sustainable and green packaging solution. So our idea is to offer a sustainable packaging solution that has all the technical characteristics of the material that was used before, so as to minimize disruption to already existing businesses and to already existing logistics and ease the transition. So we plan to become the number 1 for the green transition of packaging. And third problem, which surfaced in the meanwhile, is that in some countries, especially third world and developing countries, a lot of agricultural waste is burnt. In developed countries, there are certain circular systems that capture the waste streams from agriculture and use them to produce methane, to produce feedstock, to produce different kinds of usable products. However, in Serbia, we don't really have any mechanisms like that yet. And agricultural waste is burned en masse. And a few years ago we had a situation where the air was stagnant, the atmosphere wasn't circulating, and all of the smoke was captured around the city, which produced enormous amounts of terrible pollution. So we turned the production of our material towards waste streams, towards utilizing such waste streams. And we had the idea to try and use cellulose and lignin-rich agricultural waste to produce our material. One thing about our material is that it's not produced in a classical sense. Our material is grown. So the agricultural waste is actually used as the food stock for the mushrooms, which then grow through the substrate and grow into the shape that we want them to of the mold. As I said, we have several circular stages at our material. So the first cycle would be the fact that our material is produced from agricultural waste, and when its life cycle is completed. First to say that our material is completely biodegradable. However, it won't biodegrade in dry, normal room conditions. The only conditions in which it starts biodegrading is when it's in contact with soil and has a lot of moisture for an extended period of time. So when it's thrown outside into the dirt, into a field, into a forest. Then bacteria from the ground start dissolving it. And what happens then, and this was a study by the agricultural faculty in Belgrade, it was proven that Biosporin within 4 to 6 months biodegrades completely, does not leave any solid wastes, and it basically melts into organic salts. And those organic salts then fertilize the ground. So Biosporin actually degrades into organic fertilizer, and it can be used as an addition to fertilization for fields. So it again fertilizes the fields from which crop grow, which we then use for agricultural waste and cycle it down. Another level is that if the material is physically damaged, but not chemically, so if it doesn't start biodegrading, it can just be put back into the production process because the mushroom is cannibalistic. It will re-eat and reintegrate parts from its waste. Another line can be that when products from Biosporin are physically degraded, but they haven't been chemically damaged, they can be shredded and used as soft, instead of soft filling, instead of the pellets from styrofoam, for softer packaging. So that's another cycle which we have. And we are currently working, as I mentioned before, we also have a mushroom growing aspect to the business, and we are growing pharmaceutically active mushrooms. Now, how these two are related is that actually the entire production process is the same production process up to a final point at which they diversify into whether we will use it for production of pharmaceutically active mushrooms or we will use it for biomaterial. But then the waste from the mushrooms which are used for the pharmaceutical extract can also be returned back into the material. So we are constantly innovating in these fields and trying to make as many circular steps as we can in order to have an almost completed circular process. And we require very little resources actually. And that's also one of the problems that in bookkeeping we have with entry materials, because we can produce pharmaceutical products, tea, biomaterials of different kinds, but our only input is agricultural waste. And we actually don't use any other resources. We use some equipment during the growing, but most of it is reusable and reused. So there is very little waste in the sense of plastic bags which we use to sterilize the substrate. They are recycled. So we have quite a lot of entry points, with the only negative sides. No, the only. Of course, everything has its positives and its negatives. One of the negative sides of the production of this material is its requirement of space and time. So we use very little energy. The production process uses 98% less energy than production of styrofoam per same volume. It generates no wastewater, it generates no solid wastes, it's carbon negative, which I will explain additionally. However, the space that you would require to compare to styrofoam you have one extruder machine for styrofoam. And that machine can produce an endless amount of objects from styrofoam by simply extruding them into a form and popping them out. And that process lasts a day, let's say, for bigger styrofoam objects and a few hours for smaller ones for single object production. In our case, our material has to be solidified or grown in a space that it occupies. So our capacity to produce is limited by the space we can use for growing the material. So one cubic meter of material needs 1 cubic meter for up to a week to be completely produced. Now, this, of course, is a weakness in a scaling sense. However, we think that one advantage, next to the agricultural waste being abundant and free, basically, in Serbia, one other advantage is that space is also less costly here in Serbia than it would be in other European countries. We have a lot of unused industrial space in our country, and we believe that by utilizing part of that space, we can easily scale up production to a much bigger scale, because the technology we require is easily scalable. It's very linear in its scaling. So more space literally equals more Biosporin produced. So as I said, Biosporin has a lot of different physical qualities and can be made to have a lot of different physical qualities. Its major attributes are, number one, that it's completely biodegradable and ecological to produce. And number two, when it's compared to styrofoam, it's actually non-flammable. The material is a zero flammability class, so that means it doesn't catch fire, ever. It starts combusting, so it turns into ash at around 1,000 degrees. So it's highly inflammable, and that is a very strong bonus compared to styrofoam, leaving aside everything else. So our first target, as I said, is packaging industry, because that single-use packaging is the major source of pollution, both air pollution, land pollution, water pollution, microplastics. However, the material can also be, we have a lot of inquiries from the building industry. And a lot of people are interested in using it as a sustainable isolation, because it's very thermal isolational. It's actually has the same thermal capacity as styrofoam, so it can isolate in the same sense. We are getting a lot of inquiries from people who are building ecological homes or ecological hotels or bio cottages and similar things, who want to use our material as isolation. Now, that use is very also important, because the building industry is the second consumer of styrofoam after the packaging industry. However, the bonus of our material, so being biodegradable, also prevents it from being used as a long-term solution, because if it would happen that the isolation layer gets wet, it would start biodegrading in a while. So in that sense, it couldn't be used as natural. However, we have a project with the technological and metallurgical faculty and with a private laboratory where we are developing a coating for our material, which should impregnate it and make it completely hydrophobic. So by making the material completely hydrophobic, we are actually also stopping it from biodegrading. Now, the rationale behind this is that this coating is actually produced from recycled bioplastics. So it's also a circular moment. However, while the coating is intact, the material won't biodegrade. However, when the coating is physically broken, so if I make a hole or a puncture in it or crack it in any sense, it will start biodegrading. So this would allow us a much wider range of usage, both in wet conditions, as well as using it as a isolation for houses or similar. Also, one advantage when compared to other building materials and potential usage is that it's relatively elastic. So our material has a bigger elasticity than styrofoam does. For everything else, it can also be used as acoustical isolation. So there is a company in Italy that are using a similar material, engineered in a way that absorbs sound waves, and it has a very good quality in absorbing them as well. And some startups from the US and from Netherlands are producing furniture from this material. Now, when compared to the competition or to others in the field of producing biotic materials based on mushrooms, except for our technical differences, because we all use different technology, is that our goal, our area, is to try and produce cheap single-use packaging. So we believe that if it's something that's biodegradable, then it should be used as biodegradable. It should be used to produce something that's single-use and disposable. There isn't much logic in making something that should last forever from a material that is biodegradable. It's the same level of logic that we use something that's eternal to make something that we use once and throw away. So we are trying to capitalize on the natural biological abilities that the material has. Well, after about 3 years of development, as I said, early development was about a year and a half to get to the prototype. Then with the help of the Innovational Fund, we got to a commercial product now. So right now we're entering our commercial phase. And we have a few commercial projects running where we are making packaging for components for sustainable toilets, which are produced in Serbia and exported to abroad. And we are also working on prototypes for sustainable packaging for perfumes and for bottles, for different kinds of breakable material. So those are all commercial projects that we are starting right now, and we have a few more, as I said, pilots experimenting with different applications actively on the field to see if we can also produce them in a commercial sense. So we are in the commercial phase now, but we are still in a half manual phase with production of our material, because the equipment to produce our material doesn't exist and it hasn't been designed yet. So we actually have started designing the machines that are necessary to produce our material in a half automatic or automated sense. And we have designed the first of those machines, which we are using now. So we are using a partially automated system to produce them, but it still requires a lot of manual labor. So to properly scale up, we plan to finish designing the production process and the production machines, and then to scale up with both space and production power to be able to accommodate the market, because there is a lot of demand and there is a lot of interest, and that's definitely undeniable. The only question is how quick we will be to rise up to produce to that extent that's needed. Our main goal is to actually develop the technology for the production and package it in a neat pipeline that can then be licensed to other companies, because we have applied for patents for the production machines. So we plan to hold the intellectual properties of the production process, which we can then license out to other companies, help them develop and set them up in the market, because that's a more scalable way to do it than us having to do all the production. And we believe that this can have a lot more impact, in the sense that if you allow other startups who want to use the technology to use it for royalties, it's easier for them to start and to get into the business than it would be to have to immediately get up with the technology and money from the start. And this kind of approach will allow us the widest impact. And our end goal is to have the widest impact and to reduce plastic pollution as much as possible, and ambitiously to replace all the styrofoam on the market with our material. So there is a lot of interest both nationally and abroad for our material, and maybe our first real inclination came when we won on an international European level competition for green tech startups in clean energy area, and we won the Popular Award by voting, and that gave us a kind of sign that we are on the right direction, because votes came from all over Europe, not only from Serbia. And that made us believe that we are on the right track, both nationally and internationally. We have been contacted by the biomaterial library in New York, who want to put our material in their library as a sample and as a existing innovative material. We have been contacted also by investment funds and accelerators from abroad, who are all interested in our material. And we have been contacted by a few businesses, and as I said originally, even the idea came from a few big businesses stating that they need something like this, that there is a need for a material like this on the market. Now the thing is that we believe that Serbia has potential, and we believe that our country can serve as a powerhouse for circular economy and for sustainability, maybe especially because we need it the most. Because in other countries, there's a lot of sustainable technology already, but there is a lot of greenwashing as well. And it's very difficult to differentiate between the two. Here in Serbia, we have a kind of a clean slate. There isn't much technology in the sustainable and circular area, so there is much room to grow. We have unused waste streams, which are very cheap and easy to use here, because our legal structures also allow us to use it without much issue, which would be a problem in the European Union, because the usage of different waste streams is highly regulated. So it's easier to move here in an experimental sense. And we also, as I said, the space is here more affordable, resources are more affordable. And one of the things is that for businesses who will want to export to the European Union or to other bigger countries like the US and similar, we'll have to find a sustainable alternative. So our plan is to first offer Serbian businesses first pick of our material, so they can package and export in it, and basically lift us as well as on a national level companies from Serbia and give them a kind of a sustainable badge. We do plan to scale up our technology internationally, but it would be impractical to export the material as such. So local production is necessary. And when we start licensing the technology, we plan to basically change the main operations of our company into opening and helping new companies develop and licensing their technology in different countries. In places where there is a big need for packaging, like industrial zones, and that also potentially have access to agricultural zones for the waste streams. As we say, circularity and eco is our main thing with this material. And through collaboration with different institutes, with the Academy of Circular Economy and with the Smart Impact Fund, we developed sets of tools by which we can measure the impact of our material and by which we can calculate how much actually we are reducing pollution. So 1 ton of Biosporin that's produced and marketed successfully, so that replaces 1 ton of styrofoam on the market, reduces CO2 emissions by 8.9 tons, reduces methane pollution by 3 tons, reduces solid waste by 300 kilograms, and reduces ashes by 150 kilograms. And I'm not mentioning all the additional trace toxic chemicals that are released through plastics. So this is a summation of the different ways that Biosporin reduces. So starting from utilizing waste streams, which are then not burned but used for production of our material. By the material itself, while it's growing, it's carbon negative. It actually absorbs carbon from the atmosphere. So 1 ton of Biosporin absorbs 0.2 tons of CO2 from the atmosphere. By replacing plastic, we are preventing plastic being produced. So the emissions that happen during plastic production are reduced. We are reducing the emissions that are generated by burning the styrofoam. We are reducing the plastic waste and the microplastics that are created by having the styrofoam in dumps. And we are also reducing ash from the burning of both the agricultural waste and the styrofoam. Well, actually, when we began working on our material, we didn't even know what circular economy is, to be honest. So we actually started developing our material and then saw what it can be and what it can do. And one by one, the ideas came. And then we went to the Academy of Circular Economy. And through it, we actually realized what the terminologies are, what cradle-to-cradle design means, what circular design means, what eco-design means. And then we were able to frame what our product actually is and what it does. And through product life cycle analysis and through material flow analysis, we were actually able to quantify how much and what it reduces and where we could position it in the market so it has the biggest impact. So we realized at that point that it was circular and started pushing in that direction. Well, everything is possible with enough work, so they are possible. The fact is that they are difficult because there isn't much knowledge about circular economy at all, or ecology in general in our country. There isn't much awareness and there isn't much resources or funds. But as I said, that fact actually makes it maybe even more, yes, it's more difficult, but it's also more fertile. There is more space to work. There is more opportunity and there is more impact that we can make here. Because our impact here, where the pollution is greatest. It would have been impossible to start without the help of some institutions, definitely. So the Fund for Innovations, which basically allowed us resources for innovative development, which wouldn't be possible without that help. And the Academy of Circular Economy for the guidance that we were provided into developing an actually circular product. Smart Impact Fund, which deals with social businesses and impact businesses in general. So there are a few ways that you can actually develop a circular startup in Serbia, and it's not impossible. The resources are there, the tools are there. It just requires a lot more work and a lot more dedication and devotion to it than would be developing any other business, I think. And also Serbia isn't really, we don't have an investment culture. We don't have an investor culture and we don't have, especially not in innovations. So getting early investments is difficult in Serbia. However, my advice to anyone starting a business, especially in circular economy and especially innovative businesses, would be not to aim for early investment at all. So try to develop your idea on your own, bootstrap as much as you can, and seek grant funding money from different funds, from different sources. Adapt your idea to what it needs to be for the grant, and then develop it through that. And then think about investments later on, when you actually have a product, when you actually have an investment. Because it's going to take much more work to get those investments in Serbia, is early investments, than it will to actually make the product itself.